So today we are going to talk about network calls and how those things work within the iOS framework, how they would have worked with storyboards and how they work with SwiftUI. There are differences, so we'll cover that. And basically the learning objectives of today's class, and maybe we'll finish it today. I don't want to rush it. It's fairly complex, some of the things. So we will, make sure that we have a good understanding before forward. And these are the learning objectives. How to make asynchronous network calls to APIs. I don't know. Did you guys cover this in your previous iOS course?
No.
No. Okay.
Well, I think a lot of us use APIs, so we learn by ourselves.
Right, right.
Yeah.
So
I
asynchronous.
learned how to use like URL session to make API calls, asynchronous
Yeah.
calls based on that. Mostly like I found learned it based on YouTube videos.
Yes, yes.
But yeah, I don't know how to use Combine. I've seen a lot of apps using Combine. It's like for I think state management or something like that. Maybe you can use combine and then yeah. So yeah, and it's also like there's not enough documents with Swift UI, so mostly I'm just like spending a lot of
Yes,
time to
so
learn things by
that's what I
myself.
noticed, Shahrukh, and that there's a lot of because
I don't know if it's my internet. Can you guys hear me?
sorry.
I couldn't hear you for like last minute.
Oh,
I don't know if others could hear you, but
okay. Let me repeat what I was saying. Yeah, I see here text cannot hear you. Okay. So, hey, I want to ask you guys, when I open this chat, do you guys see it in the shared screen or the WebEx filters it out?
no, we don't see the chat.
You don't see the chat window?
No.
Okay, okay. Good to know because sometimes people send me messages privately and I'm skeptical about opening it because I thought everybody can see it and they may not want everybody to see it. So good to know. Anyway, going back to our topic, so previously, the Swift UI is a new invention. It came out as a full release not even a year ago. And what that did was because of the way the whole Swift UI framework is designed, there is not as much or similar access to the view components as you had with the storyboards. You had outlets, you had actions that you could define. Now, all of that you do slightly differently in Swift UI. What that meant was that any asynchronous functionality, network calls, etc., that you were doing on a separate thread, if you want to pass those messages to the view, all you had to do in with storyboards was to put it on the queue, the main thread, and it will come into, it will have its effect. But with Swift UI, you have this different mechanism. You don't have access to those components. So you create using Combine, you create objects that sort of that are observable and observed in the kind of like they send events from one to the other, and it all happens in the background and it has its own terminology, the way you connect all those things. So that is one big difference. And it is this is where I thought was the documentation was very severely lacking. Apple's own documentation is not very clear. So we will cover that, and I will give you a couple of other resources that I found helpful.
Hmm.
And then how to do things like when the data is received. typically in today's environment, most of the time you will be receiving in JSON format. Some might be XML as well, but we'll look at JSON and see how to parse that JSON in the easiest possible way, without making it very complicated. Something that may also correlate with what happens, for example, in JavaScript or other frameworks. And ultimately, we have to do all of that so that we can display something to the user. We'll also look at how to use a picker view. And for this, we'll use the same example. You have done this app last semester in Android, currency conversion. You might remember we made calls to an API and we would get the data and we'll display a conversion rate. So we'll use that example to learn all of this.
The Swift, Apple on Monday released Swift 2.0. We officially, I think it's developers can download from Xcode. If you go Xcode, you can download it, and it's now there is like no UI kit at all, so it's 100% Swift UI. So if you open the app, there is no app delegate or scene delegate. So that just the 5 lines of code of Hello World is a complete app, and you can publish on App Store. That's all you need.
Okay. So
Yeah.
this is Swift UI 2.0.
Yes, they release, but the thing is I think Swift UI 2.0 will maybe only work with the iOS 14.
Yeah.
So if you download it, or only the developers will be able to test it, and
So it's
no
not
one
a full
else.
release right now. It's probably in a beta release.
It is, yeah, but like because Swift UI has been in like development since like 10 years, and they releasing features incrementally. So they're adding like small features by testing a lot slowly, and they've added like couple of new features that were not
Okay.
in this one, or basically were difficult. The one example is like changing the color or appearance is where it's not available in Swift UI. You have to use UI kit. So they
Okay.
added like bunch of those things.
Okay. Okay.
Mm.
Good. So that's what this is another thing I've noticed that when I'm teaching a course like this, in the middle of the course, they will change something, they'll remove something, they'll upgrade the Xcode version. And it will create all kinds of confusion. Because the students, especially when I was teaching the other
Mm.
program, those are, that's an undergraduate program, and they don't have any real world experience. And for them, they learn a certain way of doing things, and halfway through the semester, the interface is looking different, the editor is looking different, and there is a lot of
Yeah.
confusion.
I think that Apple is pushing Swift UI a lot, and they want people to stop using the UI kit. And from since in September, since a lot of people will download iOS 14, because Apple has like very high adoption rate whenever they release an update, a lot of people immediately get that new software update. So with Swift, with new, because they're releasing their own silicon chip, so they're getting rid of Intel. So in their MacBook, they won't use Intel
Mm.
anymore. They're making their own chip like iPhone, iPad. So now you can make one app, native app, and it will run on Mac OS, iPad, and iPhone.
Oh, that's yeah, I read about it that they're
Yeah.
going to be discontinuing Intel. So that would be a good advantage.
Yeah, they were showing like they just made one app and it was running on iPad everywhere. So because they want more and more people to make Swift apps, and it would be easier that way. It would run
Hmm,
on TV OS and stuff.
very good. Okay, let's come back to our agenda of today. I also want to tell you that we'll have a midterm exam next week. So we have the Android midterm on Monday, and we'll have the iOS midterm on Friday. And I've tried this last semester. I tried it, and I found that it's just too stressful for the students. If I lecture part of the time and then give the exam the remaining, hardly anybody is able to focus on the lecture. So this time we'll do it differently. It will just be the exam. So I will design an exam that I think you guys can finish in 3 hours, maybe less. That way, I also don't want to make it too lengthy, too long. Before you joined, Hamza and Shahrukh, I was just talking to Harry, and I have an email from another student saying that there is just too much activity, there are too many assignments, projects, there is hardly any time. So I don't want to give you a midterm exam that will take you, a half a day or a whole day to complete. I think that would be brutal. If everybody did that, all the professors did that, you would have no time to, do any of those. So we'll design an exam that you can do in the 3 hours and yet be able to test many of the things we have covered so far.
Yeah, that would be nice. I messaged like other professors as well if they can lower the load a little bit. Too much right now, and we have like assignments and stuff, and because like I want to spend more time developing these apps, the Swift app and the Android app, because these are like our capstone app. And by having like so many assignments for other courses, it becomes very difficult.
Yeah, yeah. So that's why I thought of doing it. So you have the opportunity to actually wrap up the exam in the time that is allocated for the lecture.
That's good.
All right. So our currency conversion app, just to jog your memory, what we did was last semester we designed an app that you have got a list of currencies. We make two copies of the same list, and then you are able to choose from currency and to currency and show the exchange rate. And what we will need to do is to make a network call to a public API, interpret the data received, and implement a multi-component picker view with image and text. Image and text, I don't know if I will cover the image part, but we'll just do the text because I want to focus, instead of focusing on how to design the view, I want to focus on the mechanics of how the whole thing works. Uh, this also you're very familiar with. I don't need to spend time on. There are various applications of network data transfer, stock codes, weather related traffic data, all those things. And this is not just to retrieve information, you can also supply information if you have a shopping type of app, like for example, what Amazon has. When things happen, you can actually update the server, provide the data from the user, what they're browsing, etc., etc. And many of these will require authentication. We will not cover that. Authentication may require you to, for example, supply a key and something else, a private key and some sort of a hashed URL thing as HTTP headers. So the server receiving it knows that it's an authenticated request. We will not look at that. I want to, again, as I said, I want to focus on how the mechanics, how it works, and not get involved in too much of nitty-gritty. So public API that we will use, and this the same one we used earlier, this exchange rate API.io. Copy it and now paste it to your chat. You can look at it. I will open it here as well. Right, so this is the API we are going to use. And what this does is it gives us basically it returns something like this: a base currency, the date the data was, that the data is from. So it will usually be the current date and an exchange rate with respect to the base currency for all the currencies they have in their list. And the simplest request to make is this. Let's make this request and see what happens. So when you make this request, it shows you the same data that we saw there. And it's got exchange rate for all the currencies with euro as the base. We really don't care what the base is right now. And basically, if you want to go from CAD to HKD, you just have to divide. If you want to see, for example, how many Hong Kong dollars are in a one Canadian dollar, just divide this by this because the base is the same and you will get the exchange rate between these two. So that's how we'll work. We'll not bother changing anything. We'll just use this, the simplest API call to do this. We'll do the same thing as before, model view controller. Our model will maintain a list of currencies and basically provide us the exchange rates between two currencies. The view will allow us to choose the from and to currencies in the simplest way that the user can without having to type anything. So that's why we'll use a picker object. So you can just, scroll. And this part again, I don't know if we'll cover this, but this is something once you have how it works under control, you will be able to do all of these things on your own. Like, for example, add a text field and allow the user to enter a different number in there and show the amount. That would be what is the most useful feature. If you were to make a currency conversion app, nobody is interested in knowing how much one US dollar is worth in Brazilian real or whatever currency. People want to use such an app if they're traveling and they want to see, okay, how much is this amount in my currency? That's why you want to allow the base amount to be edited. So, that's a useful feature, not an essential one from the perspective of learning. So far, so good, guys. You're with me.
Yeah, I wanted to ask for the future apps, can we learn how to use a MVVM pattern, model view view model? Because I see like a lot of discussion, especially in Swift, like converting from model view controller to model view view model, and I
Mhm.
honestly I don't understand that. So I have no idea how that works or what that pattern is, and I
Okay,
wanted
so
to learn.
let's cover that in one of the future apps.
Yeah, sure.
Yeah, perfect. So here, what we want to do is basically we want to design they have a rough design, and this is basically very similar to what we did in our Android app for the same purpose. What we want is we want a label at the top that tells us, okay, if it works, I will be able to show it to you. It does not work. Okay, there it is. Finally, it came up. So we want a label at the top. And what we want is two picker views that tells us from currency and to currency. That's what we want here side by side. And in the bottom, another label where we will display the converted amount. So that's that's what we want. And in the middle, we want the two pickers. And our model is going to be very simple. We want to keep track of what currencies we have. And if we look at the data we are getting from here, we'll just use this to build our model. So this part here, you see, this is a JSON object, and it's got key value pairs, one for each currency, the name of the currency and the rate. So our model, if it holds this information, it's sufficient for us to do what we want to do. We can display the exchange rates, we can calculate the exchange rates between any two currencies and all that. So what we want also, I think in the Android app, we started off with a static list of currencies, right? And then I think as an assignment, I asked you to build the list dynamically based on what we got. Is that that's how I remember it? I don't know if you guys remember it that way, but that's how I remember it. And what we want to do today is instead of building a static list, we'll just build the entire list dynamically right off the bat. So we need to be able to pass this data along. That's what our model will allow us to do. Get this information and supply it to the rest of the app wherever needed. So this part we'll come back to and do it. So storyboard versus Swift UI. This part you have already seen how it is a different method of building the views, how we put them together. In a storyboard, it was basically only visual. You would just drag and drop and you're looking at it. And then you would create all those outlets and actions to work with the view. In Swift UI, it's like a mix. It's visual, but you see all the code that is right there. And any type of actions you want to take, you don't have access to the same methods, those outlets, etc. So what you do is within the Swift UI code itself, you've got, if you want to keep track of what changed in something, you'll declare a state variable. And if you want to format things, it's right there in the code. And because of that, what happens is there is a difference in how we make the network call. The difference comes in, and I will show you both versions. We'll do the Swift UI version, but I will show you the storyboard versions so you know the difference. And there is also a difference in how the data that you obtain using the network call, how we use it to update the view. And once again, you will see the differences I'm going to show you. So, before we get started, let me show you the app in the storyboard version of the app, right? And then we will build the Swift UI version, so you know exactly what we are getting into. So this is what the storyboard version of the app would look like, and this is the full scope of the app that I have in the slides. So you can enter an amount and it gives you the new amount. This is the picker view, and you will see it as a single thing here. But what happens is when you're doing this kind of design with a storyboard, you will put everything together and then you have a view controller. So this one here has a view controller. You can get it from this. The view controller is in the view controller class. This is how we access it from the identity inspector. And then this view controller, you will see that it implements a couple of protocols related to the picker view delegate and picker view data source. So the delegate handles what happens when the things have change in the picker view, the selection changes, and the data source tells you what is in the display, what is being displayed. So the data source methods, one of them is number of components. Any idea what this is? Equivalent, not equivalent. There is another method called number of rows in component. So when we run this app, you will see the difference. Number of components, that single wheel of the picker view in Swift, not in Swift, in iOS, in the UI kit, it allowed you to add a single picker view and then divide it into as many components as you wanted. So for example, there is a built class called date picker, which is a subclass of picker view, and it divides that one single picker view into three components: day, month, and year. So in the same way, you can divide it to as many components. So for our case, instead of adding two picker views and working with two delegates and all that, we just tell it here that divide it into two, you know, one for the from currency and the other one for the to currency. So this is what it does. So this is the default solution, $1 Canadian to the INR. You can change it and this value will keep changing. So this in the storyboard it showed as one, right? Here it allows, because we've divided it into two, it does that. So $1 Canadian, it's telling me is about 5 Chinese yuan. Does that sound correct, Harry?
Yes, it's correct.
Mm-hmm. So this is what we want to develop using SwiftUI. Now, here you will see what we have done is, we have added images, etc. We may not do that. I may give that to you as an assignment. But what we have is a bunch of outlets, and we manipulate these outlets. So we have the pickers, the outlet to the picker, to the amount, etc., etc. And these labels also change. We show the full name of the currency, all that. So using these outlets, we are able to manipulate those. A currency, a change is detected, so it tells us what is the current selection. Okay, so this delegate actually is where we build the country, the flag, we add the image, etc. And this is what is the view that is being displayed. So my view has, we create a view on the fly, and then we add one label and one image to it. So you create an image view instance of whatever the currency has been selected. Uh, for that, we pick the image of the right currency and then plug it into the image view. Have a label, we add the two things. That is what is displayed here, a label. So this is how you would in storyboard. In a storyboard, this is how you would customize your what you display here. If you want an image and a text, you can design any view, really, does not matter. And then what happens when some change happens, selection changed, then we call this update exchange rate. So this was to make a network call every time the selection changed, and our network call was happening in the conversion model. So this update exchange rate, it would take the from and to currency and append it to the URL. And what that would do is that in our API call, instead of getting the entire list, it would get the exchange rate between those two currencies. It would change the base and the target. So we're changing base to something and symbols to whatever. This is what it will look like. I'm going to just show you question mark base equal to CAD and symbols equal to, let's say, INR. Then it gives me the exchange rate directly. But it's just it's an arithmetic you can do in your app if you have the entire list, and you don't need to keep making network calls every time the selection changes. You just get everything in one shot. And it's not real time anyway. This API is very simple. It is based on a date. So this was the date they picked the data from. It changes one. So in an app that uses real-time data, like for example, if you build an app for stock quotes, you would want to display the current price, not something that was fetched, you know, previous evening. At least while the market is open, you want to display the current price. So how did that happen? So this part, I don't know if you guys are familiar with. This is how you did it. You open a URL session and you create a data task. And data task, it runs asynchronously. And when it's finished, it executes what is in this closure. It receives the data that the API returned, a response object, which is to see if the request was successful or not. And if you want to extract other things, maybe there are some headers you're interested in, maybe there are some cookies, etc. And if there was an error, it would be stored in the error object. And this is where we get the exchange rate, and then we want to update the view controller. So this is how you would do it in a storyboard. You would put it on the main queue saying, okay, view controller, we have the converted amount. Go ahead and update it. And this line here is what would actually cause the data task. You're just creating the data task object here. You want to run it. So when you run the resume method of it, it executes. When it's finished, this closure uh, gets executed. This is sort of an overview of how you would do things the storyboard way. This update converted amount will get called in view controller. There it is, update converted amount, and we have a reference to the model object. So we don't need to pass any information. Using that reference, it calculates the amount, new amount, and displays it. Displays it in the label. All right. Any questions about this method? Okay, good. So this is what you may see in apps that before SwiftUI was released, a full version. You will see this kind of methodology. You will see, labels, outlets, and you will run things on a thread and put any changes on the main queue. It's just very similar also to what we did in the Android app. We ran the URL, the HTTP connection object. We fetch the data and then we put it on the main queue to change the view. So these two are very similar. Now what we'll do is we'll create, and this is where you will join me in following along. I would like to create a new project and we'll choose Swift UI as our method of working. And use your first name, please. So any submissions make it easier for me to identify. So new project, single view app is fine. Next, make sure that you select Swift UI here if it is not already selected. These things you can leave unchecked for now. And we'll create a new app. So as always, Xcode gives us a hello world template. And what we want to do is we want to start adding our own things to this. Let me just build this so we can look at the template. So in our view, we said we want a label at the top and a picker view with two components, equivalent of that in SwiftUI, whatever it may be, we want it in the center. And at the bottom, we want to just display the exchange rate. So how are we going to do all of that? What do we need?
So do we need to put that as a separate component?
Yes, I saw what you wrote in the chat. We need a VStack. We need to basically embed this in a VStack. So now we can drag and drop more text and pickers and all of that, whatever we want. So this one will change to the sort of a title label. Okay. And I'm just going to add another label here. And for now, I'm just going to say from currency to currency. We'll come back to this, how to change this dynamically. Right? So we've got these two. Now what we want is we want a picker. And picker is still available to you as an object. Then drag and drop it between the two texts. Right? So this is very simple. The picker object in SwiftUI lets you build right here. So if we wanted to add a flag, for example, instead of saying text, you may put a horizontal stack with two components, an image and a text. That's fairly straightforward. And what this is doing is here, it is putting a label picker. So it puts something here. You may not want this, we don't want this. So what we want to do is first thing we want to get rid of this, and we want to see how to build this part dynamically. So in order to do, let's take one step at a time. Let's get rid of this picker. One way to do it is you can make the label blank, but it still takes up space. So let's look at the documentation and see how we can just get rid of it, make it without so it doesn't waste this space. And the second thing we want to do is we want to be able to divide this into two, just like we did in the storyboard, because that's a neater user interface. So how do we do that? Let's see if I have a slide about it. So this much we have done. If you want to change the background color, etc., it's totally your discretion. Placing two pickers side by side. So in the storyboard, I showed you the method where you could specify the number of components. SwiftUI doesn't let you do that. You have to actually use two pickers and put them side by side in a horizontal stack. And I'm going to paste this link for you as well, and I'll open it here. So in a horizontal stack, you see this guy has an example right here. In a horizontal stack, you can put one next to the other. I don't know what his question was. Does not resize pickers. That's a good one. We'll see how to size it as well. So for now, what we want is we want this picker to be in a horizontal stack and put another one right next to it. Okay, so we've got the two pickers here. But you see what happens? Each one of them has the same width, which is the entire width of the device, and they are still side by side. So now what we want is we want them to each have half the width. Do you remember how we did something like this in one of the previous classes? We need to know how wide the screen is and divide it into two. And assign that as the height, not the height, the width. So does the name Geometry Reader ring a bell? This is what we want. So the way to do it is to stick it into a geometry reader and use the geometry to specify the frame for each. The frame for each one of the pickers. That's what we want to do. And these kind of things you may have to do. Geometry reader. We want to embed it, right? And this in the closure, you receive an argument called geometry from the geometry reader. It tells you how big the space available for this, whatever is inside it is. So let's do that. This closure, it is going to close here by default. And now we will close the geometry reader, and Android Studio does a slightly better job. It will have automatically indented your code. We'll do it manually, doesn't matter. So now we've got the geometry available to us, and now what we want to do is we want to change the frame. And what happens is that by default, let's just go with this one, frame, width, height, and alignment. So our width now is whatever is the geometry, the reading dot width divided by 2. What is the problem? I think I have the, okay, I need to get the size object from the geometry. It's not geometry dot width, it's geometry dot size dot width. So let's do that. And the height we can specify whatever we want. So if we want, let's say, we want this to take 1/3 of the space. Let's do that. Geometry dot size dot height divided by 3. And alignment, we'll be happy with whatever alignment let's go with center aligned. So now you will see that this view, this picker is half the width, but this one is still the full width. Just copy and paste this code here. Now they are side by side and they take up half the width and 1/3 of the height. So we are happy with this so far. Okay. All right. So we've got two pickers side by side now. Let's see what we can do next. So the way what we want to do next is how to, I don't think I have it here. There's one more link I would like to give you, which is how to update list of picker data. Let's go with picker dynamically, right? How to update it dynamically. And for that, I have here another page that is open, which I thought was even better documentation than Apple's own documentation. This guy has explained it nicely. So let's copy that link here, and I'm going to paste it for you. You can save it. All right. So this link is what I'm going to, I'm pasting it for you. You should receive it. What does it show us? How to work, how to work with a picker object in an, using that combined framework. What this guy he's doing is he has a data center object and he wants to show in the picker views some information that he retrieves from the internet or something like that. So here is what a picker view allows you to do. You can use a for each statement to iterate over whatever is your collection of information that you want to work with. And this is where combine comes in. You see this data centers controller. This is an observed object. So what happens here is SwiftUI builds all the connections in the background. Because this is an observed object, SwiftUI knows that whenever there is a change to this data center's property of this observed object, it needs to rebuild this picker. And it does this by iterating over all the objects in this data, all the whatever the way it is stored, it's usually going to be an array. All the elements it is going to iterate over and use the some property of that element to populate the list. And this is the actual observable object here, the class. And what it does is it implements the protocol observable object, and this the variable it is being that is being tracked here is declared as published. So not everything is published. So it may have other variables here which will not be published. What that means is that any change to the value of those variables are not signals to whoever is observing. So this mechanism, whenever you change this property because it has the attribute of being published, that change is propagated throughout whoever is observing that object. And a notification will come here. And this guy here, it knows because this is an observed object, and whatever change that was published in the code, it knows where it is being used and it will redo that part. It will recalculate that view. And you cannot use everything inside the views here. In this closure of the picker, certain things can be used. If you try to use something else instead of for each, if you said for and then you use this array, it won't work. There are some limitations to what you can put inside SwiftUI because it needs to be able to do certain things at compile time and certain other things at runtime. So we'll get into a bit of that shortly, what it expects from us. But this is the general construct. For each some property that is published and use that property to build your picker. So what we'll do is we'll start with this part here. We'll use the data center controller, this example, but in our case, we'll just build a class for observing, for fetching the data for the currencies. So let's get started with that. We will create a new file, a Swift file, and we will call it currency data model. And we'll create that file. It will come in as an empty file with just the foundation framework. Let's define our same class name, and this time we will make it an observable object. Might want us to import combine, I don't know, we'll find out. And here we need to publish okay, before we go there, we need to track currency rates and currency names. We need to correlate. So the way, if you follow the same thing here, you need a struct and you make an array out of it. And there is a reason why this has been done. And you need to understand that what that reason is. You see this struct data center, it has certain behaviors. It implements certain protocols. One of them is identifiable. So what happens is that this for each statement, it expects an identifiable here. Let's look at the documentation. Even I haven't looked at it. SwiftUI for each. Right, so this is what it expects. Data ID content, structure that computes views on demand from an underlying collection of identified data. So without that, if we were to sort of, build an array of things that are not identifiable, then we have the work of telling it what is the ID, because it expects a certain ID to be associated with each data point. That's what identifiable does. So then it becomes our job to make sure that that ID is not being repeated, and each element has its own ID. So this is something you can also delve into some more. What we are looking at is we will use this same thing as identifiable. We'll implement this codable and hashable. Hashable also, I think internally what it does is it creates a hash to make each object, to ascertain that each object has a unique ID. So without it being hashable, it won't do that. And codable is probably optional. It allows you to save this. If you use core data, you will be using, everything needs to be codable to be able to saved and retrieved. So that's what this struct is doing. We want to use this. Let's go with it. Currency data. And we'll go with the same hashable and identifiable. And it needs to have two things. In our case, let me just go back to our storyboard version. What we did was we have an array, like more like a dictionary, where we store, well, actually, I'm sorry, this is not equivalent, because here we're not storing all the data. We just compute it on the fly and return it. So it's not a fully equivalent functionality. So what we want is we want to be able to store this information that the API is sending us. We want the name of the currency and a double value that represents the exchange rate. So we want a name which is going to be a string. Let's call it name and see what happens. String and var rate double, right? These two. As soon as you do that, it's going to complain. It's going to say that your currency data does not conform to protocol identifiable. And what is the problem? If you say fix, it will tell you. It needs an object identifier. It needs an ID. So we have a choice. We can define a different ID or we can just rename this variable as ID. And that will fix that problem. See, when you create a currency data object, you know that only one object can exist for a currency. Our base is fixed to euros. So INR you will only ever create one object with the ID as INR or USD or whatever it is. So that way we can call this, make this an ID, and it is going to be unique. Each object is going to have its own unique ID and there won't be any multiple copies. So far, so good. Okay, good. So see, so we've got this. Now what we want is we want to be able to keep an array of this currency data here, and that is what we will publish. So anytime we get new set of data, it will send an event, it will publish it, right? So at published are, let's call it exchange rates, and currency data. I will create an empty array. We'll initialize it like this. So this now is setting up a mechanism that whoever is observing this object, because it is an observable object, anytime any published value changes, that observer will receive a notification, a signal in the background, hey, this thing changed, right? So now what we need here is, the next thing we need is an initializer. And this is where we'll make the network call. And populate exchange rates object. So what that will do is that will set us up. So when we populate this, our network call is going to be asynchronous. It will happen, it will take whatever time it takes. When it's finished, from the data we'll create this exchange rates array. And because it's a published object, we will receive, and we will make this, we'll create an object of this object and make it an observed object here in our content view. So that's what we are going to do. And this seems like a good point for us to take a break. We are halfway through, roughly. So let's break here, and then when we come back, we'll create an object of that type and we'll start building our connections. We'll start the network call and see how to process it. All right. Any questions before we break?